Good day. For those of you who do not know us, we are the instructional staff for ECE 150, professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to look at namespaces, and then we're going to look specifically at standard cout and introduce the class standard OStream. So in this topic, we will describe the namespace keyword. We will look at the standard namespace, and we will then describe some of the reasons for using namespaces within your code and within projects. We will then describe standard cout and how it is an instance of the class standard OStream. We will then also look at the very interesting implementation of standardendline. All right. Up until this point, we have used, without serious explanation, the STD or standard namespace. We have seen it with types such as standard size t, class names, standard string, function names, standard sign, and objects such as standard out, and we'll get more into this soon. Now we're going to discuss namespaces and how and why they are necessary in C++. And in fact, namespaces are used in numerous other fields, including, for example, XML. Now, suppose you want to author yet again another sign function, but you don't want people calling it unless they really want to. So for example, here I have a sign function that uses a spline approximation, at least on the interval from 0 to pi over 2. Outside that interval, it uses the standard properties of the sign function to map back onto that interval. The problem is, anyone could accidentally call sign, and this is the function they may call. The way we can avoid that is to wrap this in a namespace. So in this case, namespace is a keyword in C++, and the identifier of this namespace is ca_uarlu_dwharder, because this is the function I authored. Now, if I wanted to use and explicitly call this version of sign inside my function, I would prefix the function identifier with the namespace using 2 colons. Alright, so at this point you should understand how the sign function is defined inside the standard library. It is defined within the namespace std or standard. Now, more or less everything in the standard library is in the standard namespace. And these are some examples once again. There are a few exceptions when macros were brought over from older C libraries, such as the assert statement and the constants from the C math library, such as m_pi. Now, currently in the standard library, there is no such thing as a secant function. So if you wanted one, you could author one yourself. So the secant function simply returns 1 divided by whatever the standard library call to cosine returns for cos of x. All right. Now, as I said, currently the standard library does not contain such a function. However, suppose there was no standard namespace, and suppose that a future version of the standard library did include a secant function. Well, this is going to do one of 2 things. It's either going to break your code. The compiler is going to indicate that there are now 2 different definitions of seek, or it will very carefully inspect both definitions and then call the one you didn't mean. Now, this isn't going to happen because seek will never be added to the standard math library in C++. However, in companies, it's very often to call a function init. for initialization. And so multiple different groups may define an init function that does completely different things. However, it may happen that as the code is brought together from the various subgroups, those names may clash. If you're lucky, the compiler will let you know there's an issue. If you're unlucky, well, yeah. Now, warning. There's nothing special in C++ about the standard namespace. If you wanted to, you could actually just add more additional global variables, functions, or class definitions to the standard namespace. Well, nothing, except of course in the words of John von Neumann, that you would be in a state of sin. You're probably not going to gain significant respect among your colleagues either if you pull such a stunt. However, point being, STD is just an identifier, and it is an identifier used for the standard namespace. Now, one nice thing about namespaces is that they ensure that the introduction of new identifiers in one namespace never affects anything else in any other namespace. So, for example, a company may have a global namespace. So here we have the namespace com_Cyberdyne. And this may include company-wide classes, functions, etc. If you wanted to call any function, let's say there's a function f defined within this namespace, you would have to call it prefixed by com_Cyberdyne:f. Now, a project within Cyberdyne could have a namespace within this namespace or its own namespace. So here's an example of a namespace within a namespace. Within the com_Cyberdyne namespace is the namespace Skynet, and this would include the Skynet-specific classes and functions. Now, if you wanted to call a function f within this namespace, you would call it with com_Cyberdyne:/Skynet:/f. And now you could call either this function f with this prefix, or if you wanted to call the company-wide one, you would just use com_Cyberdyne:/f. Alternatively, a company may simply choose to give a slightly different identifier for the namespace. So instead, you may choose com_Cyberdyne_Skynet, in which case, if you wanted to call any function defined within this namespace, you would just use that namespace, : and the name of the function. Now, every single group or project in a company could, without issue, accidentally perhaps, use the same function name, and it will not adversely affect other projects or other groups within the company. Now, one point. In this course, all you have to understand is the idea of how a namespace is used and how it is used to prevent the collision of identifiers. Specifically, in this course, we're using the standard namespace. Now, the first object we saw in the course was actually defined in the standard namespace. Specifically, cout is an instance of a class called oStream, or output stream. Now, just to give an example, there's another object in the iostream library that is called clog, or console log. It is also of type oStream, and you could print something to either cout or clog. Now, by default, everything that is printed to clog is also directed to the console. However, there are mechanisms within the operating system to redirect any statement sent to clog to have that sent to a file instead. So anything printed to cout still appears on the console, while anything printed to clog is sent to a logging file. Now, the next identifier from the standard library you saw was standardendline. Now, you may think that this is also an object. However, it's actually the name of a function. It is the name of a function in the standard namespace that has the identifier endline, and it takes an OStream object that is passed to it by reference as an argument, and it returns, presumably that same object, also by reference. So basically, when cout sees a right-hand operand of the left shift operator that is a function name, it actually just calls that function with standard cout as an argument. If it was standard clog, then you would see it calling standardendline with the argument standard clog. So you could actually author a different function just like this. Here we have the function bob, which takes an OStream object by reference as an argument and returns that OStream object. So what this does is it sends to out the string bob with 3 exclamation marks. It then returns that object. You can then run this function. Here's a program that sends bob to standard cout, and which then sends standard end of line. So this will actually call that function, which then prints bob to the screen with 3 exclamation marks, and then prints an end of line character going to the next line. Now, this is not what's important here. The way that end of line character printing is done in C++ is not that relevant. What's relevant here is that we have a function that takes objects as their arguments and returns objects as well. And in this case, it does something. Specifically, it modifies it by having printed bob to the screen. This looks a little bit weird, but it actually works. You can explicitly call standard end of line with a standard cout as the one argument, and that will indeed print an end of line character to the screen. But this is very unconventional. So, following this topic, you now understand the namespace keyword, you have an idea as how the standard namespace is implemented and the purpose of prefixing such identifiers with std::. You also know how to define your own namespaces, and you now have a better understanding of how standard cout and standard end of line work within the context of C++ classes, and you understand that standard cout is an object, it's an instance of the standard OStream class, and standard end of line is a function that takes a standard OStream object by reference and returns by reference that same object. Now, this isn't critical to this course, but understanding this material will give a little bit more sense into what we are going to discuss in the next few lectures, especially with operator overloading. Here's the references, the colophon, and a disclaimer. Cheers!